Made to create similar to blood shot that are homology based prediction. So use many programs for gene predictions. But gene prediction predict coding region only not enough. So we need the other one, prediction promoter. And prediction in promoter in prokaryote based on the consensus sequence TAAT at the position minor 10. Minor, that means upstream compared with the start site. The other consensus sequence minor 35. And this guys repeat again. Transcription unit in prokaryote. Transcription unit may contain one promoter, one gene, the name monocitronic RNA. In case overall, that means one promoter plus a number of genes, polycitronic RNA. That the transcription unit in the prokaryote different with the eukaryote. Eukaryote, one promoter control one gene only. So that's why when we run the program, predict gene in prokaryote, also predict whether gene organized into operon or not. So this slide show you transcription start site, that the plus one and upstream minus the upstream. Eukaryote carried out by different polymerase in the location of the promoter, not defined. We classify into core promoter, proximal promoter, little promoter. So the distance quite different with the start site and also have a different function. The core promoter, the name, in what the consensus sequence TATA box, core promoter. And core promoter also have regulatory promoter. Now we move to the other one, rostral. The length 250 base pair in the position, the upstream or downstream. So that's why let's define compared with the prokaryotes. In what consensus sequence branson, the consensus sequence branson. And you look at here, because for transcription in eukaryote requires several enzymes, not only RNA polymerase. So that's why we have the gene have many regulatory sequences. And this one shows you the consensus sequence branson. Another one, little promoter and 500 base pair upstream of the start site. That little promoter. The other one we call Prozac sequence. And here, the consensus sequence for the Prozac sequence. And this one, the ribosome recognize where to start translation. In the software, we also have many software to predict promoter. Another one, for eukaryotes also need program to detect intron and exon, and how to detect intron and exon based on the boundary between exon and introns. Look at exon and introns. So the exon and introns, exon first and intron, we call donor, exon intron boundary donor, and characterized with a common sequence GT, U, that means T, okay, TT, the common sequence, and GT present in the intron, not exon, remember that? And then intron also next to the following exons that we call intron exon boundary, and this one acceptor. And acceptor characterized by AG, okay? And AG also present in the intron, okay? Another one, A, present in the intron, the brain poise, because this one have to remove introns. We don't have time, so I will show you how to remove introns. Based on AT or AG, or TT or AG, but TT and AG also highly common sequence. The other region also have TT and AG. So that's why make program difficult to predict accurately. So the gene with multiple exons and the gene with single exon and different promoter. And little promoter for enhance biter to increase expression. The last one, predict RNA secondary structure. Why is RNA came from secondary structure? Because intra-strand phase bearings. So that means one region can complement with the other region, can pair with the other region within one strand. So that's why we call intra-strands. In several forms of secondary structure, not least stem several, the name, that secondary structure present in the RNA, and how the program to predict based on thermodynamic favor. That means not require energy, minimum energy to make the secondary structure stable. If require energy, that means very active and unstable structure. So that's why we predict the secondary structure of RNA based on minimum free energy. Okay, that ends. We go to reviewing session. Three slides. Lecture 1. Definition of bioinformatics. Okay, and bioinformatics definition is emphasize on study based on three macromolecules, DNA, RNA, protein. The other ones related to computational biologies. We study the whole systems, biological, behavioral, and social system. The difference between two fields. Make sure understand the difference. Here, have to name polypeptide with different subunits, the number of units, And the unit the same or different. Okay, name of protein with many subunits. The name of the template DNA strain and non-template strains. Different name, non-coding strain, anti-coding antisense, or codings or sense strains. So what difference between terminal exon and internal exons? Okay, in one difference in internal compared with compare between exons, because act about exons between terminal and internal, also act about introns. And some slides just finished in lecture 6 about introns contain splice site, but exons no splice site. Remember that? I just show you the splice site, nucleotide adenine. Okay, that's the splice site and present in intron only, not present in exons. So transcriptomics and genomics. Genomics study DNA. Transcriptomics study gene on ready and press. So the key word and press to identify genomics or transcriptomics. Before we go further, I explain the question structure. The first one, to form short answer, multiple choice, calculation. Then pack A. Pack B, computer. Okay? And I divide into pack do with pack A first and pack do with pack B first. I don't want any student access to the same link at the same time. That the process takes very long if many students access one link at the same time. So that's why I divide into two. And you bring calculator, not laptop. You can bring anything. Don't bring laptop and smartphone.
Teachers, for the question, we have the correction. If the sentence is false, do we have to correct this?
No need to do that.
Yes, thank you.
I don't require you correct it.
Yes.
Even I don't require